The methods by which we build applications have certainly changed quite a lot over the years, if you actually stop and think about it. Back in the 60s and 70s, and probably even before that just a little bit, people would have to write a specific computer program to run on a specific computer system, and so you would have specialized teams of programmers who only worked on, for example, the IBM 360, and they would have tapes or whatever storage media they used, and they would go to these people who operate certain computers at large companies generally, and they would sell the software directly to that company. So it would be a physical thing that this company would buy. You would buy this tape that you can put in your IBM 360, and then suddenly the computer behaves in a certain way and you achieve the desired result. That was the first phase in software, in applications, right? You would literally buy the entire piece of software on a physical storage medium, and it would work specifically on your company's computer because your company only had one computer. Then there emerged the ability for programs to be written that could run on multiple computer systems. So languages like C emerged as a way to write software, and there was a standard interface defined between how multiple computers could run the same program, even though they weren't the same kind of computer. And so systems got more compatible, and software got more powerful, and more value was able to be achieved by the creation of better software. Then we started to plug computers into each other in the 80s and 90s. And that's where we emerge into the world of the internet. And so now you can write software that sits on a computer, and then other computers can plug into that computer and use the software without needing to download and run the program physically themselves on their own device. So this standard emerged for computers to now have a standard interface, right? A standard interface by which they could communicate, and then software got more powerful and more value was able to be added, because now not everybody needs to run every software program, and we all get to run, different programs and communicate with different computers. Moving into the 90s/2000s era now, we have desktop computers, and there emerged a standard interface between these desktop computers and the internet itself. There emerged this thing called the web browser, and now, instead of just, dummy terminals telnetting into something and using a command line program, you have people able to click around and visit these systems. So there emerged a standard interface between computers and web servers, and software got more powerful and more value was able to be added because of this added capability due to this standard interface. And in all of these cases, it allowed for competition, zooming all the way back out, going back to the 60s and 70s. Once there was a standard interface that allowed the same software to run on multiple computers of different kinds, then, somebody would come along and say, hey, I made a faster computer and your software is still going to work on it because of this standard interface. And that made it so that computer companies had to compete with each other. And then moving on a little bit later, now because of this standard interface between computers, you could say, well, my computer can offer you this program, and this other computer over here can offer you this other program. And therefore, computers had to compete with each other to actually host the best software, right? the fastest ways of achieving the end result desired by the user. It led to more competition. So then when websites popped up, the process becomes extremely evident, because now people can pick which websites they want to use, and the websites compete, right? The website that gets all the users, of course, is going to win, because, you know, once you're a user of that website, then you can't necessarily leave and go to another website. But that's beside the point. The websites had to compete. They had to vie for users, because there was this standard interface between web browsers and web servers. So web server software had to compete. Websites had to compete, and actually web browsers had to compete too, because now there's things on both sides of this interface, and now, you know, it's not a given which web browser you can use. I mean, most people actually can use multiple web browsers now, and just use whichever one is the best for them at that particular moment. A standard interface emerged, competition ensued, and more value was created. Even in the world today, application development continues to evolve with mobile applications. Now we have mobile devices, and applications get shipped on these devices, and there's a standard for how applications can be published. Of course, there's iOS and Android, but within each of these platforms, there's a standard interface that apps can use to plug into users, and that's their device, right? So different apps can emerge for the same thing, and then people can pick which apps they want to use. So a standard interface emerged, and then people had to compete, and then more value was added, more capabilities, more power for the user, right? So this process leads to a question. The question being, what is the next evolution? What is the next standard interface? What is that next thing, that next protocol that people are going to get on board with? What is it going to do for people? And how is it going to be more valuable based on the competition that ensues on top of it? Because once a standard interface is defined, and once it becomes adopted to a certain extent, competition ensues. People try to, while following the standard interface, provide the best functionality, right? The standard interface becomes an engineering requirement rather than a question of, well, should we follow the internet protocol? Oh, I don't know. I would rather use X.25. Should we use HTTP and HTML? No. I think I'd rather use, I don't know, what is it called? CBRL or something? Or XML? Or SGML? No, that's not a choice anymore. Now it's a requirement, right? Now it's a requirement. Because when that is a requirement, you have more people engaging in more competition, and you have more value created. So I say that the next standard interface is going to be identity. I say that the next generation of applications is going to need to provide identity as a standard interface, and they're going to need to agree on this, right? An identity layer for the internet, a layer that allows people to own the data they create and share, a layer that allows encryption with keys held by users, a layer that maybe allows payments, micro payments for the services used by users, the searches they perform, the messages they exchange, the things they share, so they can pay directly and have privacy and have their identity owned on their own devices. And when all applications plug into that standard interface, the competition that will emerge to put the user at the center, to provide the best user experience, and to create the most value, that's the competition we need right now on the internet. So I look forward to helping build the next standard interface between applications and user identity, so that we can create a more fair and value-centric internet. And that's what Project Babbage is about, and that's what the MetaNet is about, and that's what Bitcoin's about. Thank you.